Hi everyone, and welcome to this Valkyrie Sound miniseries, where we're looking at the different ways we can manipulate game audio using data generated by a custom blueprint. We created our blueprint in the first video, and in this, the fourth video in the series, we're going to create a harvesting system inspired by Homeworld. We'll be creating audio and some visual effects. We only need one sound for the harvesting activity. I've used an engine sound from my Cyberpunk City sound pack, and I've set it to loop indefinitely. As it turns out, this sound is pretty similar to the one used in Homeworld. Next, we drag that sound and we drop it in the audio components section of the player character blueprint. I already have it there, so I'm going to delete it. With the sound cue we've just dragged in selected, on the details panel on the right hand side, type in UT and make sure that auto activate is unticked. That's going to prevent the sound from playing when we spawn our character in the game. Now, if you've been following the series, you'll have already created a player chatter sound cue, similar to this one. If you haven't, well, check out video 3 in the series where we look at how to put the chatter sound cue together. For this tutorial, we'll need two types of harvesting related chatter. Harvesting chatter, for things like commencing harvest, and a resources exhausted chatter, for things like resources exhausted. These categories should already be in our player state enum, so we can call them from within the player character blueprint. One of the defining features of Homeworld's resource collecting for me is the little cone that points at the rock or the dust cloud that you're harvesting. So that's what we're going to create next. First, in the player character blueprint, we'll add a sphere component and a cone component. These are under the basic shapes section, sphere and cone. And when you add the cone in, make sure it's a child of the sphere. So you want it slightly indented underneath. If you're also using this fan-made ship model from Homeworld 2, which was created by Mr. Hohenheim on Sketchfab, these are my transform properties for the sphere and for the cone. We're going to hide these meshes in the game until the player starts harvesting. In your materials folder, right-click and create a new material. I've called mine m_harvest. On the left-hand side, change the blend mode to translucent and the shading model to unlit. We're going to create several layers of texture that will pan across one another at different speeds and at different sizes, and that's going to mimic the Homeworld resource collector's effect pretty well. So I'm using two textures from Epic's Content Examples demo. We're using the fire texture, and we're using a modified ceiling fire texture. I've used GIMP, which is a great and free drawing tool, and I've drawn in some black sections on the texture that our material will render as transparencies. First, add a texture coordinate node. I've set the U tiling and V tiling to 0.75 each. Then we're going to add two panner nodes. Set different X and Y speeds. I've halved each value on the lower panner, then connect each panner to its own texture sample node. I've added the fire texture to the top sample, and the fire ceiling texture to the lower one. Hook both the RGB outputs to an add node, and that's basically it. This is one little cell, and you repeat that for as many layers as you would like, ensuring that each of the texture samples are connected to an add, and that each pair of add nodes is connected to another add. And keep doing that until you're left with a single add. Then add two multiply nodes. The final add node goes into the A of both multiplies, and for the top one, the B value here is 6, and for the lower one, the B value there is just one of the outputs from one of the add nodes. Connect the upper multiply node to the emissive color pin, and the lower multiply node to the opacity pin. You can experiment with different textures, different scales in the texture coordinate nodes, and different panning speeds. That's pretty much it. What you should have in the upper left there is a swirling fiery orb. If not, I've linked Eric's answer in the description so you can check that out. Once that material is sorted, apply it to the cone and sphere in the player character blueprint. And then with both of those selected, scroll down on the right hand side and untick visible. So that's all the prep done. Now we're going to create the harvesting process in the player character blueprint. We're going to create 5 variables. The first 3 are booleans. These are can harvest, is harvesting, resource depleted. The 4th variable is an actor called current resource, and the 5th one is a float called harvest rate. The default for that one is 0.05. We're going to use the H key to initiate harvesting, so right click and with context sensitive ticked, type in KEYB space H. From the pressed execution pin, add a branch node and click and drag our can harvest into the condition of that node. If that's true, we're going to set is harvesting to true. So click and drag, set, make sure that's ticked and hook that up. Next we'll drag in our sound cue audio component and we'll add a fade in node. The fade in duration should be 0.5. Then again, peeling off from SC harvesting, we're going to add a play node and hook that up. And finally, we'll add a reference to the enum that we created in the last video, and we'll set that to resource collector harvest. Next, from the H key's released output, we're going to set is harvesting unticked, so that's now false. We'll drag in the sphere harvesting and set visibility. Now as you can see, we can use propagate to children. I haven't done that, but you can. We're going to leave this unticked. We'll drag in another reference to our sound cue. We'll drag out and we'll have a fade out. And we'll set the fade out duration to 0.5. Then also dragging out from our audio component, we're going to add a stop delayed node. This is a great little node. It does exactly what it says on the tin. Put the delay time then of 0.5, the same as our fade out duration. And finally for this section, we're going to add another set enum player state, and this time we're going to set this one to ambient. Next we have our resource detection section. So I'd originally planned to use the line of sight data engine that we created in the very first video of the series, tailoring it to scan for resources, but it's quite overpowered for what we really need here. We just need to know if the resources are near enough to the player for them to begin harvesting. So what we'll do next is add a collision sphere. And back in the viewport, select the root, add component, scroll down until you see sphere collision, and then set the sphere radius to 250. I already have one in there, so I'm going to delete that. And I've renamed mine resource collector trigger, but you can call yours whatever you like. With that component selected, right click in the event graph, and you can either type in or scroll down to collision add on component begin overlap. And once you've added that in, it'll deselect the component, so reselect again, and this time add in the collision end overlap. From the begin overlap node, pull out from the other actor pin and add an actor has tag node. Set the tag to resource, no spaces. From its return value, add a branch node and hook that up to the overlap node. Next, drag in our current resource variable as a set and connect the other actor to the input and hook that up to the true output of the branch. Basically, if the actor has that particular tag, we're going to set it as the current resource. Next, there is a print string, you don't have to include that. And finally, we have our can harvest variable as a set, and for this top one, it's going to be ticked. From the end overlap node, we're also going to have the actor has tag, again connected to the other actor output pin. Update tag to say resource, you can just copy and paste that down there. Add another branch in, and from its true, we're going to set the current resource, but we're going to leave the input blank, so that's going to set it to nil. Again, debug. And finally, we add the set can harvest node again, but this time we leave it unticked. Next, we need some functionality that's going to update the direction of the cone, so it always points to the resources, to scale the actor resource, and to trigger harvesting and harvesting chatter sounds. So let's create a custom event. I've called mine harvesting. And from there, I've added 2 branches, one for can harvest and one for is harvesting. If both are true, we go to a sequence node. For the upper line, drag in a get for our current resources variable. And from that, add a get actor scale 3D node. From the return value of that node, we want a vinterp2 node, which gives us this here. The target is going to be 0 because we're going to shrink the actor, the current resource actor, down to 0. Now in the last video we created a delta tick. This is a variable that we promoted from the event tick's delta seconds output. Hook that up here to the delta time input of the vinterp node, and the harvest rate float variable we created earlier, plug that into the interp speed. That's going to affect how quickly our resource shrinks as it's harvested. From the current resource variable, add a set actor scale 3D node, and hook up the new scale 3D to the return value of the vinterp2 node, and then hook that up to the top line of the sequence. Also from the return value, I'm going to pull out and we're going to break that vector. Because we're decreasing its size in all 3 directions at once, we only need to pull out from 1 pin. But what we're going to do is we'll pull out from this pin and we'll do a less than and change the lower value to 0.1. If it's less than 0.1, if it's less than 1/10 of its original size, we're going to destroy the resource. So from there, add a branch, hook it up to the set actor scale 3D node. From the true output of that branch, add a set resource depleted node. That's from our variable before, and make sure that's ticked. Then adding in another reference to the current resource, peel off from there and destroy actor. So next, from the lower sequence output, we're going to change the visibility of the sphere and cone. So we can just copy and paste what we had before, and this time we're going to tick the new visibility box. That's going to show both of those meshes. Drag in another reference to our sphere, and from this we want to get world location. Drag in a reference to our current resource, and this time we want get actor location. From the top one, from the get world location, if you type in find look at rotation, it's going to give you this node here, and plug the actor location node from the current resources into the target. The rotation pane, if you drag out from that and set world rotation, and we want this for the sphere harvesting, or whatever you've called it on your side, hook that up to set visibility and make sure sphere harvesting is the target plugged in there. From there, we're going to add a branch for our resource depleted variable. If that's true, we're going to set the enum player state to resources exhausted. Paste in another copy of the set visibility section, this time with new visibility unticked. That's going to hide those meshes. And our last little section here is from that visibility node, a new sequence node. For the top line, set our resource depleted variable to false, unticked. Then add a delay in that's equal to the longest length of our player chatter sound cue. So by that, we just get in a reference to the player chatter sound cue that we created in the last video. Get sound, that's the blue hoop. Get duration, and then we plug the duration value into a delay duration input. And finally, we're going to set the enum player state back to ambient. For the second line of the sequence node, drag in another reference to the SC harvesting sound cue, and we want another fade out node. Again, the fade out duration is set to 0.5, and again we're going to add in a stop delayed node with a delay time of 0.5, and make sure that's also hooked up to the harvesting audio component. The delay section we've added in here, we could probably set this to almost any time really. That's just in case the ambient sound gets triggered very quickly. Adding this little section in here creates a little bit more space between each of the chatters. So our last action that we need to take in the player character blueprint is from our event tick. We're going to add in a reference to the harvesting custom event we created earlier. Call function harvesting, and that's it. So now we're going to create a resource that we can harvest. Now you can use any mesh you like for this, as long as it's a static mesh and so long as it has collision applied. So I'm using the cliffs and palm tree meshes from Epic's vehicle game project. So this, for example, right click on it, we go Asset Actions, create a blueprint using this. It'll ask us where we want to store it. Just put it into the place where you normally keep your blueprints. I'm going to call this resource Cactus 2. And with the very topmost element, the very topmost component on the left hand side selected, in the search details section, if you type in tag, it'll say actor here, add an element, resource, compile, save, browse to that blueprint, click and drag it in, and now if we hit play, movement order received. No signs of active life. We should be able to harvest this cactus. And there we go. And the cone will update as we move around the cactus. And it gradually shrinks as we... Harvesting command received. And it gradually shrinks as we harvest it. Collecting resources. And that's it. One thing I have noticed is that due to the navigation mesh, very large resources that block out part of the mesh prevent the player from getting close enough to completely devour the resource. Show the navigation for those. You can see that this area is blocked. The player won't be able to go into there, but it can get as close as possible. Would you look at that? And if we harvest, it will shrink. Harvesting command received. But once it gets to a certain size, it won't allow us to harvest any further. Looks like we've got the upper hand. So that's something to bear in mind. You might not really be able to have huge resources, or you may just need to look for a different way to get around that problem. But for the purposes of this video, we've covered how we can generate chatter depending on the state of the player, adding in a new state, harvesting, harvesting, harvesting. And that's it for this video. In the next video in the series, we'll trigger sounds for the AI weapon, adding sound effects and particles for impacts and near misses. Thanks very much for watching, take care, and as always, enjoy making your own projects.